All right, guys, in this video, we are going to begin the section 4.5. This is a printed out packet I'm linking to our Canvas page, so make sure that you check that out. So if you need to print that off at home or whatever so that you can follow along. Otherwise, you can totally do this on a normal piece of paper. Just make yourself a table and little kind of graph grid and work. So it's just kind of nice for it to already be printed out and everything ready to go. Anyways, what we have studied up till now is we've done graphs of sine and cosine, which they both made this kind of wavy pattern. However, the tangent function is a little different. So it's going to have different characteristics. And so we need to discuss how that looks. And so what we're going to do here, just to begin with, is we're going to try to discover what the tangent graph looks like. Now, I want y'all to keep your unit circle handy. This is mine, so I've got it so I can reference, because in order to find tangent, what we tend to do is we just divide the sine by the cosine. If you remember from your unit circle, on our unit circle, your x coordinates were cosine, the y coordinates were sine. And so to get tangent, we would do y divided by x, sine divided by cosine. And that way we can find the tangent pretty easily. Okay, so what I'm going to say is maybe have a piece of scratch paper handy, maybe have your unit circle nearby. And what we're going to do is I'm going to kind of get you started on this table that I'm going to ask you guys to try to pause the video and then complete it. And then we'll kind of come back and I'll show you what the answer should have been. All right. Okay. So like I was saying a minute ago, we're going to use the unit circle to help me. We're going to find what the sine and cosine are, and then we'll be able to tell what tangent is by dividing them. So at pi over 6, according to my unit circle, again, I'm looking here at pi over 6, the y value is 1/2. That's the sine. The x value is square root 3 over 2. That's the cosine. So sine is 1/2. Cosine was square root 3 over 2. And for us to figure out what tangent is there, just going to do this right here, tangent of pi over 6. The way I'm going to calculate that is we're going to do the sine, which is 1/2, and we're going to divide that by the cosine. This means you have to remember how to divide fractions like you did back in elementary school. Keep, change, flip is the phrase most people tend to show or talk about. I always say multiply by the reciprocal because that way you're using mathy terms. Either way, that's what happens. You change to multiplying, you flip the second fraction, you get the reciprocal. And then we see these two are going to cross cancel. This is 1 over the square root of 3. Now, I don't like to leave my answers with the square root on the bottom as a personal choice. Technically on your test, if you leave the square root on the bottom, it will be okay. But if I multiply square root 3 top and bottom, I can rationalize it so I no longer have a square root in the denominator. Would be square root 3 over 3. So technically either one of these answers is correct. I just like to get the square root out of the denominator if at all possible. All right, that's tangent. Now, if we're talking about graphing, let's be honest, graphing something and saying graph that value is a little bit tricky. What I would suggest is figuring out what the decimal for that would be. If I post it for a second. And the decimal for this guy is about 0.58. So as far as graphing this goes, that will be easier. Okay, I'm going to pull my unit circle back. We're going to look at pi over 4. All right. Pi over 4, sine is root 2 over 2. Cosine is root 2 over 2. So those are the same. And when you divide something by itself, sine divided by cosine here, you're going to get 1. So that's easy. All right, pi over 3. Let's bring this back. Sine is going to be square root 3 over 2. Cosine is 1/2. So it's going to be kind of similar to our first one, except the order's changed. Okay, so I'm going to bring my little Post-it note back. I'm going to put our work here. This is going to be tangent of pi over 3. All right, so I'm going to be taking the square root 3 over 2 and dividing that by 1/2. So what's going to flip is the 1/2 this time. 2's cancel. Sorry, this is square root 3. 2's cancel. You're left with just square root of 3. Okay. All right, I'm going to do one more, then I'm going to let you guys try the rest of them yourself. So pi over 2, again, bring back your unit circle. At pi over 2, my sine is 1, my cosine is 0. And then when you find tangent, you're going to divide sine by cosine. 1 divided by 0 is undefined. If you have 0 in the denominator, it's undefined. If it's 0 in the numerator, your answer is 0. So you got to look out for which one is which. Okay, here's the moment where I want you guys to pause the video and fill out the rest of both of these tables. Okay, use your unit circle, go through. You're going to see a bunch of values repeat themselves. That is normal. Okay, so go ahead, pause your video. All right, guys, once you have done that, I'm going to need you to check your answers. So what we have right here is the tables filled in all the way. I also went ahead and included an input of 0 because I think it's important to have that. So, and see what's going on at 0. So double check your answers, make sure that everything lines up. You can pause the video to do so. And we're going to go down to graphing this. A lot of people look at these tables and they say, I don't know how I'm going to graph this because there's so much stuff in the table. Okay, so I want you to back it up and say, okay, look at what we're working with here. Sine and cosine, the whole purpose of them was to help you figure out tangent. We're not going to graph sine and cosine. All I'm going to be looking at here is my input x's, those are the radian measures, and then my output are the y's, that's the tangent. So I would have a coordinate pi over 6 root 3 over 3, or 0.58-ish. Okay. Another important feature is to recognize that the square root of 3 would also be easier to graph as a decimal. It's about 1.7. So definitely check that out. And you end up getting those type of answers for everything. So we shouldn't have any other irrational numbers that we can't figure out. Okay, so on your graph, we're just going to go ahead and start with this. Try to figure out how we're going to place these values on your graph grid. Okay. So the first one is pi over 6 for my x, and then 0.58-ish for the y. Now, pi over 6 is a little bit tricky to find. If you're looking at the graph grid that I've provided, the way that it's scaled is by pi over 3s. You're seeing here is 0, then pi over 3, 2 pi over 3, pi. I don't see pi over 6 listed, but that doesn't mean it doesn't exist. They just didn't label it. So where is it? Pi over 6 is going to be directly between pi and pi over 3. So if you look right here, this right here is where pi over 6 lives. Okay, and you can mark it if you wish. I'm not going to mark every single one of these because it just becomes tedious, but we can mark some. All right, pi over 6, and then I'm going to go up to 0.58-ish. So that's a little more than halfway to the 1, just like that. All right. Then we need pi over 4. Again, that one's not marked. I want you to remember a couple different ways you could remember where this is supposed to be. On your unit circle, pi over 4 is directly in between pi over 6 and pi over 3. It's exactly halfway between those two. It's going to be exactly halfway between them here as well. So I could look between the pi over 6, pi over 3. Here's where pi over 4 would be. Okay. Another way to do it is to count. There's 12 units between the 0 and the pi. Pi over 4 would be like divide that by 4. 12 divided by 4 is 3. So it should be 1, 2, 3 units over. Either way, this is where the pi over 4 lives. And I'm going to go up and plot a point at 1. Okay, next one is pi over 3 and then 1.7. Now pi over 3 was nice and listed. 1.7, we got to just kind of eyeball. It's going to be about there. And then we get to this weird value, pi over 2 undefined. For the time being, I'm going to skip that, and we'll come back in just a minute. 2 pi over 3, negative square root of 3. So remember how we had square root of 3 over here was 1.7? This is going to be negative 1.7. So at 2 pi over 3, we're going to be at about negative 1.7-ish on your graph. Okay. At 3 pi over 4, that's my next one. Again, you can eyeball where your pi over 6 is going to be. This is going to be the 5 pi over 6 right here. Pi over 4 is between those two. Okay? So this is going to be 3 pi over 4, and then down at negative 1. 5 pi over 6, and then negative a little more than halfway down. Then we get to pi 0. There's a point. All right, I know I'm going through this kind of quick. You can always go back and rewatch if you missed something. I've got to go to the next part of the table. Let's go ahead and get these marked as well, okay? So 7 pi over 6 square root 3 over 3. Remember that this value is about 0.58. And I want you to notice, if you haven't already, if you see all of the outputs in the top table, they're the exact same outputs in the bottom table. So you can kind of follow a similar pattern to what you've already had. So I'm going to go here. Let's see. The next one I'm supposed to do is 7 pi over 6. Remember, pi over 6s are between the pi and the pi over 3s. So we're going to see pi over 6 is about right here. And that is where, hold on, pause. Yeah, I'm blind, y'all. Okay, this is where 7 pi over 6 is. I second guess myself because my eyes are not very good. All right, so there's 7 pi over 6. We want to go up to about 1.5 or 0.58. We've seen that height before, so I'm just kind of like going off of that height I already had. The next one's going to be the pi over 4, 5 pi over 4, go up to 1. 4 pi over 3, we're going to be going up to 1.7, sorry. Then we get to this 3 pi over 2 undefined again. I'm going to skip it, and we'll come back. Negative square root of 3. We're going to go to 5 pi over 3, negative square root of 3. Going to be about there. Then we're going to get to the 7 pi over 4, which should be 1 unit over. And then over here, 2 pi. Here we go. All right. Now, remember how we had a couple different values that were undefined? They were undefined here where it made that big jump. It was undefined here where it made that big jump. So let's connect, and also we should have a point at 0, 0. Let's connect what we have, but don't connect between where it said undefined. And I want us to try to visualize, see what is happening here where those undefined things were. And I don't have a hole, but what we do have is a asymptote. A vertical asymptote goes straight down through here. That's why you have those undefined values, is because you have those vertical asymptotes. So it's kind of neat. Whenever you see that, you can just know that's where that was. We are going to mark those, so make sure you include those asymptotes in your picture. And then we're going to go to the next part of the question. So they said, how long is one cycle of the graph that you drew? What is the distance from the first x value to the last x value? So if we look here, and I see where it starts repeating one cycle. See, we started here on my x-axis, and it went up. That cycle ends at pi. Because if you notice, after pi, you get the exact same thing repeat itself. Okay, so this cycle was pi units long. That's the period of tangent, which is something we've talked about previously. Next thing says, what's the distance of the graph from the minimum point to the maximum point? And on this, guys, I would say that this is kind of a trick question. They're trying to see do you recognize the fact that this continues up for forever and that it goes down for forever? Do you recognize those things? And because there is no minimum, there is no maximum, then you can't really recognize a distance between the two. You could say infinity if you wish. That would probably be the simplest answer because you can't really calculate that. And if there is no minimum or maximum, there is no amplitude. So they said, is there an amplitude? No. All right, I need y'all to pause the video again and graph the rest of your tangent function. Continue this pattern and then come back when you're done. See if your stuff matches mine. Okay? Go ahead and do that. Hopefully we've done. It should look something like this. It does not reflect back up. Some people try to do that. It does not reflect back up. You get this pattern over and over. until you run out of space. So graphing tangent, there it is. Okay, now with that being said, we are going to jump to some of our handwritten notes for just a minute, and let's see what happens with our tangent graph. Okay, we will come back to this packet in just a few minutes, so definitely don't let this go too far away from you. Okay, so in our handwritten notes for this section, we're going to start off with tangent and get a little bit more example type thing with it. So this is section 4.5, tangent, cotangent, secant, cosecant. And you're going to see I've got this little tangent graph. It's not as detailed as the one that we just did, but I do want you guys to pause the video and get this copied down and then come back when you're ready to go through example 1 with me, okay? Example 1 asks us to describe the graph of y equals negative tangent of 2x, okay? We're going to locate the vertical asymptotes and graph 4 periods worth of this tangent function. So I'll get my other piece of paper here. I'm going to raise this up. Okay, so describing the graph, keep in mind our normal tangent function and the way that it looks. But when we have this negative in the front, most of us could probably already know what is going to happen there. It's going to end up flipping your graph across the x-axis. So as far as describing this thing goes, I'm going to say that there's a reflection across the x-axis because of that negative. And then this 2, when it's inside of the x, that is going to represent your horizontal dilation. So we're going to say a horizontal. And it is always different than how it looks. It is not a dilation of 2. It is of 1/2. So you've got to remember that horizontal dilations, you have to look at the reciprocal there. Okay, now we could probably add something to that in a minute, but let's see what else we can figure out. So they said to locate your vertical asymptotes. Because this horizontal dilation is of 1/2, it's going to shrink it horizontally and shrink it in towards the y-axis half as far. So I want you to look at what our normal tangent function looks like. Normally, we have asymptotes at pi/2, 3π/2. They're the odd increments of pi/2. This is not going to be the case. Because it's shrunk in, instead of being at pi/2, those asymptotes will be at pi/4 and then 3π/4. So those asymptotes are going to be in different locations than where they normally are. So we're going to say at odd multiples of pi/4. And that should take care of where those asymptotes are. Okay. Another thing is that your period is going to be shorter because this is 1/2 dilation. Normally the period is pi. Period is not going to be pi. The period is going to equal it's going to be pi/2. It's half of pi. All right, let's graph this. We're going to graph it the lazy way, all right? So let's talk about what's going to happen. If we said that there are asymptotes at odd multiples of pi/4, then if I start to mark this, I can mark it a similar way to what I had before up above. But if I'm going to mark this thing, I could go pi/4 is going to have an asymptote. If we say pi/4, we could then say here's pi/2, right? Here's 3π/4, and there will be another asymptote. Basically, between these asymptotes is 1 period. We're supposed to be graphing 4 periods. Down over here at negative pi/4, we should be seeing another asymptote. Okay. So that's 2 periods worth. Let's go. Here's negative pi over 2. Here's negative 3 pi over 4. There'll be another asymptote. Okay, so I'm seeing those. This is 3 periods worth. I need one more period. It doesn't really matter which direction you go, or if you decide to split it and make it centered, you can do that too. If we get over here to, this is a whole pi, and then this guy would be 5 pi over 4. If you really wanted it to stick on the right side of this thing, that would work. And then we know that this is going to hit the x-axis in between. It's, sorry, it's supposed to flip across the x-axis, so it's going to go upside down. So instead of going up, it's going to go down. Go down. This is kind of the lazy way of doing it, but we are hitting some important points. We're hitting where that x-axis, where it hits the x-axis, and we're showing those asymptotes and the direction it goes in. Okay, I've got things labeled so I know where it's hitting the x-axis. That's important. So this is still considered like a lazy graph, but it's good because it tells us important values. We can see values on here. It's not just a picture of what your calculator would look like with no values actually shown. It's important for you to be able to know those. So include that when you're doing problems. All right, guys, I am going to stop the video here for tangent, and because this is about what I would expect to be able to get through in a class period. So what I'm going to say is to definitely stay tuned, because in the next videos, we're going to be discussing more and more graphs. The next one will be cotangent. So stick around for that one. I'll see you in the next video. Bye.